equation designed especially for you. Now, these two functions both have minimum values very, very close to each other. You'll recognize the square root of x plus 2 is starting at negative 2, and it has a value of 0 there. And then the absolute value of x plus 4 bottoms out at negative 7/4. This is a V-shaped object, and this is more of a curve. So we're looking at curves intersecting lines, basically. Now, as I just mentioned, the domain of the square root of x plus 2 is minus 2 close to infinity. All right. And also, both functions are increasing on minus 7/4 to infinity. Both functions are increasing their nature. All right. Now, actually, it turns out the absolute value is actually decreasing from minus 2 to minus 7/4, but it doesn't really make any difference as far as the floors go. Now, so since we can't start at a number less than negative 2, we might as well start at negative 2. And if you substitute negative 2 into both of these equations, this is the floor of 0, which is 0. The floor of any natural number or whole number is the whole number. Then right here, minus 2 plus 7/4, that's minus 1/4. Absolute value of minus 1/4 has a floor of 0. Now, I'm not going to go through all those calculations each time, but we know that at negative 2, they both share the same floor, and so it's a non-empty solution set, and negative 2 is contained in it. And I could have left this out, but just wanted to verify with you. When you put minus 7/4 in, you also get floors of 0, so it's also contained in the set. So now we have to think about when will the floor actually change, okay? Well, that's actually going to happen at negative 1 for the square root function, okay? If you put minus 1 in for the square root function, you get the square root of 1, which is 1. All right, so you see it's actually changing floors, and that's why we're leaving it out of the solution set here, that part of the solution set. Now, notice that minus 1 plus 7/4 is still equal to 0. That would be 3/4, and the floor of 3/4 is, of course, 0. So what we know for a fact is that the closed minus 2, the open minus 1 is contained in the solution set. All right, now let's move along. Okay, now the next number we tried was, this looks kind of arbitrary where we're checking, but notice now, last time the floor change took place at the square root function, now it's going to take place at the absolute value function. And we picked minus 3/4 because that's when it changes from 0 to 1, the floor of the absolute value. All right, and so then now, okay, just keep that in mind. So it changes to 1. All right, and they're both equal to each other. All right, now the last relevant floor change has to be 1/4, and that's because, again, the absolute value function is going to change to 2. 7/4 plus 1/4 is equal to 2. Okay, now notice we're getting to a point where the absolute value function is starting to really outgrow the square root function, because look, already it's at 2, and the square root is nowhere near. This would have to be the square root of 4 to have a floor of 2, right? We're nowhere near a square root of 4, so you can already see how quickly the absolute value function is outgrowing the square root function. Now, so, and again, I was going to leave this kind of as an exercise, but this is the last relevant floor change just simply because if you take a look at what happens here at 2, the square root function has to go all the way to, has to go all the way to 2 before it even has a floor of 2. But correspondingly, the absolute value function has a floor of 3 at that same point. So we know we can stop at 1/4. And again, we have to leave 1/4 out because this would be a floor of 2. So they wouldn't agree because the square root function still is at a floor of 1. Okay, so the union of those two sets, let me back up just a little bit. This was kind of the result from the first part. All right, this outline blue piece. All right, and now we have to union that. So the union of these two sets is the overall solution to the original equation. That's a little messy, but if you have an idea of what the graphs look like, and then the fact that they started more or less at the same spot, it's kind of hard. It's easier to make some of the decisions. The fact that the functions are increasing and continuous with no jumps also makes the solution a little bit easier. Okay, hope y'all enjoyed that.